Alright, so today we're going to focus on negative exponents. So far we've been looking at positive ones, so let's take a look at what happens when we start playing with negativity here. So let's consider two ways of looking at this following problem. So I want to begin by using algebra here. So consider 2 to the second power getting divided by 2 to the fourth power. So if we use the algebra here, we can expand 2 to the second as just 2 times 2. And then the denominator, 2 to the fourth, that's just saying to multiply 2 by itself 4 times. So now we can cancel out common terms from the numerator and the denominator, so we can get rid of these 2's and we can get rid of these 2's. So now we're only left with 2 times 2 on the bottom, which is 2 to the second power. And then here on the numerator, it looks like we don't have anything left, so we actually just have a 1. You can think about multiplying a 1 there. So we have 1 over 2 to the second power. That's by doing algebra. But now let's take a look and examine the same problem with the property of exponents that we learned in the previous lesson, which is the quotient rule. So the quotient rule tells us that whenever we have the same base and we have an exponential expression getting divided by another exponential expression, we can subtract the exponents. So here we have 2 to the second power minus 4, and here we get that this expression is equivalent to 2 to the negative 2. So now we see that on the right hand side here, this expression equals 2 to the negative 2. But on the left hand side, we see that the same expression equals 1 divided by 2 to the second power. That must mean that this expression is equivalent to this expression. And that's exactly what we do. We say that 1 over 2 to the second power is equivalent to 2 to the negative second power. And from this observation, we're going to develop a definition. So here's the definition. Suppose n represents a positive exponent and x represents a base. Then, if we take the negative of that exponent, this is going to be equal to 1 over x being raised to the positive version of this exponent, which is what happened here in this problem. So here, 2 raised to the negative 2 was equal to 1 over 2 to the positive 2. Alright, so let's exercise this pattern a bit with some examples so you can get a feel for them. So let's begin here with 3 to the negative 5. So here, if we use the definition of a negative exponent, all we got to do is write 1 over 3 raised to the positive 5. And that would be it. This would be my answer in exponential form. Let's do it with a variable now. So now here, if we apply the same rule, all we got to do is do 1 over x to the positive 3. Alright, now we can do this with any real defined base. So here, we can apply this to 2x, as long as we consider 2x to be the base, which it is because the parentheses are emphasizing that they're all getting applied this negative 2 power. So here we write this as 1 over 2x to the second power. Alright, let's do one final one. So here xyz raised to the negative 1 can be rewritten as 1 over xyz to the positive 1. And we can clean this up just a little bit. We don't have to emphasize that power of 1. So we can write it as 1 over xyz.